parametric equations and the coordinates that we had discussed till now had their vertex at 0, 0. Now what will happen when the vertex shifts to some other point? Suppose the parabola has its shifted vertex and the vertex has now shifted to some point we can take as h, k. So the vertex is new and is shifted from 0, 0 to h, k. This is the coordinates of my vertex. Now in this equation, see the parametric equations of y minus k whole square is equal to 4a x minus h are given by x is equal to h plus 80 square and y is equal to k plus 280. And why have we received these equations? See, if this is the equation of the parabola that is given to you, then if you look closely, this resembles capital Y square is equal to 4a capital X. So what I am doing, I am taking capital X as x minus h and capital Y as y minus k. If I make these two transformations, I can replace this equation by y square is equal to 4x. Now for this kind of parabola, we have already discussed that the parametric coordinates are given by x is equal to 80 square and y is equal to 280. These are the parametric coordinates that we have discussed for the parabola y square is equal to 4x. But in this case, what is the value of capital X? Capital X is given by x minus h. So x minus h is equal to 80 square. And what is the value of capital Y? Capital Y is given by y minus k. So y minus k is equal to 280. So from here you can say that x is equal to h plus 80 square and y is equal to k plus 280. So what is the only difference that we can see in these parametric coordinates? That we have to add the shifted vertex. The coordinates of the vertex which were h and k, we had to add it to the parametric coordinates that we had received when the vertex was at 0, 0. So when your vertex shift, the parametric coordinates also change because the equation of the parabola changes with respect to your vertex. So these will be the new parametric coordinates when the vertex is at the point h, k. Similarly, the way in which we have found it for y square is equal to 4x, you will have to find that for y square is equal to minus 4x also, x square is equal to 4ay also, and x square is equal to minus 4ay also. The same way in which we have solved it for y square is equal to 4x. For all these parabolas, if the vertex shifts, there will be a change in the parametric coordinates of these parabolas also. The question that we are discussing now says that the parametric coordinates of any point on the parabola whose focus is 0, 1 and directrix is x plus 2 is equal to 0 are. Now two things that are given in this question are the coordinates of the focus and the equation of the directrix. If I draw these two things, suppose this line is your x plus 2 is equal to 0 and this is your suppose x-axis. If this is your x-axis, then the point of intersection of x plus 2 is equal to 0 and your x-axis will be what? Minus 2, 0. Because x plus 2 is equal to 0 implies what? That x is equal to minus 2. That means any point on this line x plus 2 is equal to 0 will have the x coordinate at minus 2. But on x-axis, the y coordinate is 0. So this point will become minus 2, 0. The focus is given to you as 0, 1. Suppose this point is 0, 1. This is your focus. The one thing that we have to find in this case is your vertex. Vertex will be somewhere in between this directrix and focus. The second thing that we had done when we were discussing the standard form of a parabola was that the distance between the vertex and the focus and the distance between the directrix and the vertex is equal. That means vertex is the midpoint of this point and your focus. How will you find out the coordinates of the midpoint? If I take the coordinates of vertex as h, k, then h will be given by what? H will be equal to minus 2 plus 0 by 2, which will be equal to minus 1. And what will be the coordinates of k? K will be equal to 0 plus 1 by 2, which is equal to half. So what are the coordinates of your midpoint of the vertex? The coordinates of your vertex are given by minus 1, half. If you try to find the parametric coordinates, then you know that the equation of the parabola with your